Hello everyone, welcome to Brain Blitz Audios. In this episode of Cbse board exam, we'll be dealing with previous year questions of mathematics in Cbse board exams. The chapter that we'll be dealing with today is the second chapter in the grade 12 syllabus for Cbse. The name of this chapter is Inverse Trigonometric Functions. So we'll be looking at functions such as sine inverse, cos inverse, tan inverse, cot inverse, sec inverse, and cosec inverse. So stay tuned and grab onto your seatbelts. We'll be blitzing through some questions of Cbse board exam. Are you ready? Here it is. Write the value of tan inverse of 2 sine 2 cos inverse root 3 by 2. So when these kind of questions come and we have to find the value of this, the first thing that we need to do is to look at what quantities are present inside the innermost brackets. In this case, that is 2 cos inverse root 3 by 2. So this small bracket is similar to the form 2 cos inverse x. And the formula for 2 cos inverse x is cos inverse of 2x squared minus 1. Let's apply the formula in the inside brackets. So the whole value will become tan inverse of 2 sine and then 2 cos inverse root 3 by 2 will become cos inverse of 2 into root 3 by 2. The whole square is 3 by 4 minus 1, which we can now write as 2 sine cos inverse of 3 by 2 minus 1. 2 goes into 4 twice. And then 3 by 2 minus 1 will give you tan inverse of 2 sine cos inverse of 1 by 2. So we have cos inverse of 1 by 2 now in the innermost bracket. And 1 by 2 is the same as that of cos pi by 3. Cos pi by 3 is 1 by 2. Let's put in the values. So it will be tan inverse of 2 sine cos inverse of cos pi by 3. And now it's just easy. You can remove cos inverse and cos because they are reciprocal functions, so they get removed. So you get tan inverse of 2 sine pi by 3. So how do you reduce this further? We know that sine pi by 3, that is sine 60, is equal to root 3 by 2. So now we'll put that in the value. Tan inverse of 2 into sine pi by 3, that is root 3 by 2. 2 gets cancelled, so we have tan inverse of root 3. Tan inverse of root 3, so we know that tan pi by 3 will be root 3. Tan 60 is root 3. So we have tan inverse of tan pi by 3, which is equal to pi by 3. So the value of tan inverse of 2 sine 2 cos inverse root 3 by 2 is pi by 3. So using a formula and the values of sine, cos, and tan, sine, cos, and tan pi by 3, we got the value of this complex inverse trigonometric function, which is just pi by 3. Let's look at our next question. Using the principal values, write the value of cos inverse 1 by 2 plus 2 sine inverse 1 by 2. So since the question is asking us to use the principal values, it pays to know the principal value branch, which is just the domain of the function of sine inverse and cos inverse. Cos inverse x is equal to theta and the theta belongs to 0, pi, closed interval 0, pi. So this in effect is the range and not the domain. That is the answer when we plug in the value of x. So sine inverse x is equal to theta, and this theta belongs to minus pi by 2 plus pi by 2, which is again a closed interval. So now let's start solving this. Cos inverse of 1 by 2 is just the same as cos inverse of cos pi by 3, because cos pi by 3 is 1 by 2. And sine pi by 6 is also equal to 1 by 2. So we'll get cos inverse of cos pi by 3 plus 2 sine inverse of sine pi by 6. And on deleting the inverse and the original function, we'll get pi by 3 plus 2 into pi by 6. And therefore, it'll be pi by 3 plus pi by 3, because 2 goes into 6 3 times, which will give you 2 pi by 3. And there you have it. That is our answer. Next question. Find the principal value of sec inverse minus 2. So let's know the range of the sec inverse function. And the range for this one is 0 to pi minus of pi by 2. The reason being at pi by 2, the value of sec inverse goes to infinity. And when we have studied trigonometric functions last year, you would know that sec pi by 3 is equal to 2, because sec pi by 3 is 1 by cos pi by 3. That is 1 by 1 by 2, which is equal to 2. Now, since sec pi by 3 is 2, we can write sec inverse of minus 2 as minus sec pi by 3. So sec inverse of minus 2 will be equal to sec inverse of minus sec pi by 3. Sec inverse and sec gets canceled, so we get minus pi by 3. However, this minus pi by 3 is not belonging to the interval, closed interval 0 to pi minus pi by 2. This does not belong because it's less than 0. So this answer is not the right one. How do we do this? Let's go back to this part of the answer. Sec inverse of minus sec pi by 3. We'll write it as sec inverse of sec minus pi by 3. And since sec is negative in the second quadrant, we can write sec of minus pi by 3 as sec of pi minus pi by 3, 180 minus theta. And so the value will be sec inverse of sec 2 pi by 3, which will give you the answer as 2 pi by 3. And this belongs to 0 to pi except pi by 2. So when we're writing the answers to principal values, it is important that first we need to check out if the said value fits into the range of the inverse trigonometric function in the question. Let's do another problem. We'll do this last problem today. Write the principal value of sine inverse of sine 3 pi by 5. Again, this one looks simple. Let's write sine inverse of sine 3 pi by 5. And so that will be equal to 3 pi by 5. Right? Wrong. This is incorrect. The reason why is when you do, just try dividing 3 by 5. So 3 by 5. And yeah, so 0 point, and then put a 30. It goes 6 times. 5 goes 6 times to get 30. So that is 0. So we have 0.6. What's the point in that? Well, the sine inverse function has the range minus pi by 2 to pi by 2. So the angle theta should belong to this range. But 3 pi by 5 is 0.6, while 1 by 2 is just 0.5. So it will be 0.65 pi, which is greater than 0.5 pi. So essentially, this does not belong to minus pi by 2 to pi by 2. Therefore, this answer is incorrect. How do we convert this? Well, we know that sine is positive in the second quadrant. And since we have 3 by 5 as the given angle, we'll convert it to pi minus 2 pi by 5. So yeah, 1 minus 2 by 5 will give you 3 by 5. So similarly, pi minus 2 pi by 5 will give you 3 pi by 5. And the beauty of this is that sine is positive in the second quadrant. So sine of pi minus 2 pi by 5 will also give you sine 2 pi by 5. And sine inverse and sine will now get canceled. So it becomes 2 pi by 5. And 2 pi by 5 belongs to minus pi by 2 to pi by 2. This thing belongs to the function. It is essentially the same value, but this angle theta now belongs to the sine inverse range. And how do I prove it? Just do 2 by 5. So 0 point, and then a 20. 5 goes into 24 times. 20 minus 20, that's 0. And 0.4 is less than 0.5. 0.5 is 1 by 2. So 0.4 pi will be less than 0.5 pi. So 2 pi by 5 is obviously greater than minus pi by 2, but it is less than pi by 2. So that makes this the principal value of sine inverse of sine 3 pi by 5. So that ends this episode of CBSE board exams. There are a lot of questions, 1-mark questions and 6-mark questions regarding inverse trigonometric functions. But due to time constraints, we won't be able to discuss everything. So don't worry, we have a whole playlist dedicated to CBSE board exams, and we've had a couple of other episodes earlier regarding inverse trigonometric functions. So be sure to check them out. I'll provide their links in the description down below, as well as the link to the whole playlist of CBSE board exam, so that you can revise other chapters such as, say, relations and functions, matrices, determinants, etc. So if you want to stay connected to us and learn more about our interesting and useful content, then please subscribe to our channel, Brain Blitz Audios. You can also click the notifications button in the description down below. That will help us in informing you via YouTube's technological setup, our latest updates. So we can update you on our latest content if you click that notifications button. So stay tuned to that. And until the next episode, take care, stay safe, bye-bye for now.